Welcome back to this ray tracing series. This time I'm going to put some materials on our spheres, that is color. And I'm going to start by renaming this old RGB class to Pixel RGB, because I want to use the RGB name for something else. And we create a new material class. A material will have a color of type RGB. And the RGB class will hold our colors in red, green, blue as floats this time. And before we give our spheres a material, I want to remove some duplication on how we create spheres. So I'm going to create a function sphere that takes the scale and the position of a sphere. And I take the old way that we create a sphere and put it inside the function and replace the values with the parameters that we give it, and replace how we created our old spheres with our new function call. A bit cleaner, and we still have our spheres in when we render. Let's create a new material, let's say a red material. So we also create constant for red color. And let's also create for green and blue. And while we're at it, let's create black and white colors. Now we can create a few more materials, let's say green and blue. And we add a material to our new sphere function. And we put in a couple of red spheres and a couple of green spheres and some blue spheres. And to give a sphere a color, we create a new class, a shape with material. Shape with material will take a shape and a material. The intersect method will be similar to the one in transformed shape. If it's a miss, we just still return it, but if it's a hit, we will return a material hit instead that takes the hit and the material. Create the material hit class that takes the hit and material, and we add a material to our hit interface. And in our surface hit, I'm gonna create a default material that will be returned if we don't give any material to our spheres. Let's make it a gray shade. And we delegate our material to the hit. And let's create the multiplication function so we can scale colors down. We just multiply each color channel with a constant. Back in our view model, now let's just create our material color if we have a hit, and we need to convert our color to a pixel color, our old RGB class. We do that by just taking each color channel and transform it into a byte. We also coheres it in to be a value between 0 and 255, so it can fit inside the byte. And there we have colored spheres. And now we can start using the material. We start by fetching it from the hit, and then we create a new variable to collect all light that hits a shape. First we have an ambient part, that is how much light a shape gives when it's in total shadow. So the ambient factor tells how much of the color will be from the shade and how much will be as a diffuse part, that is the inverse of the ambient factor. And we add an ambient factor to the materials. And of course we have to add it also to the default material. If we now render it, it will be only the ambient light of the shapes. If light doesn't contribute, we no longer return black color, so we remove that. But if the light hits it, we will add back the diffuse part of the material. But now we collect the shade from the material itself and add it to our collected light. We add the plus function to our RGB class. And now we have the diffuse part back on our spheres. And now let's handle this specular part. We add a specular color, let's just use white for now, and the smoothness factor. The higher value of smoothness, the smoother the object will appear. And we add the specular part to our collected light by fetching the color of the light from the material and also the exponent, that is the smoothness. And of course we have to add it to our default material as well. And that's it. We have our highlights back. And that's how we add material to our shapes. Thank you for watching. See you in the next one.